How's it going? It's me. Well, I dressed up as my own emoji today, but I could do this all day, but to be honest, I probably need that snack break more than you do. I just didn't eat that much alone. I'm just not much of a barbecue person, you know. Anyway, I'm Godfrey. That's me. You can find me on the internet as Champion Code. Before we begin, got to do the Snapchat. So if you cannot share for me, that would really help with the internet points. So are you ready? Good to go? All right, let's do this. Wait, come on. Let's try it again. All right. Oh my God, welcome to EmberConf Canada. I'm so excited to be doing the closing keynote for EmberConf Canada. I work at a local company called Tilda. We make lanyards. But if you like our lanyards, you probably also like our performance monitoring product. We have a booth outside. And if you like our lanyards, you'll probably also be into cryptocurrencies, and you should check out our ICO. You can find it at skylight.io/feficon.ico. This is what it looks like. Someday it's going to worth a lot of money. But if you like money that much, you should also sign up for Skylight using this referral link, and that way you and I both will be swimming in Skylight credits. Or you can just come to the booth, and we have a $50 promo code there as well. And finally, if you maintain any open source Ruby apps, you should definitely come over and sign up for a completely free account. So with that out of the way, let's talk about debugging. Before we dive in, I just want to set some expectations. If you are a new developer, I had you in mind when writing this talk, so I really hope I can help. If you have been programming for a while, and Ember is your first or primary programming environment, this talk is also for you. I know sometimes debugging in Ember could be intimidating or even a little bit frustrating, so I hope to help reset your expectation of what debugging should be like, and at the end I will mention why debugging in Ember might feel a little bit more difficult and what you can do about it. And finally, if you're an intermediate or advanced developer, then you probably already know everything I'm about to tell you. And this talk is probably not going to blow your mind. But I would like to invite you to follow along and think about how we can more effectively teach these things to new developers and what we can do to improve the debugging experience for everyone. So let's get started. I've been pretty obsessed with failures lately, specifically engineering failures and catastrophes. Not because I enjoy watching people suffer, of course, but I'm quite fascinated by the ways that we manage to analyze and learn from these mistakes that we make. A lot of things happened in 2017. However, one of the things that didn't happen was plane crashes, specifically crashes involving commercial passenger jets. You see, we've flown over 4 billion passengers last year, which is more than half of the world's population, pretty mind-blowing. And yet, there was not a single fatality in commercial passenger jetliner in 2017. That wasn't always the case, though. In the early days of aviation history, flying was a pretty risky business. In fact, it was so risky that the early MAL pilots called themselves members of a suicide club. They ain't wrong, because it was later calculated that their average life expectancy was as low as 900 flying hours, which is roughly how many hours a commercial pilot fly every year today. And since those early days, we have invested a lot of resources into improving the safety of flying for everyone. And in the modern aviation days, every accident is very heavily scrutinized and investigated, with the results of these investigations leading into new regulations and engineering improvements to prevent the same kind of failure from ever happening again. So every time you fly today, in some ways you fly safer in parts because of the pilots and passengers who lost their lives in these hard-earned lessons. So going back to 2017, outside of the aviation history, one of the unfortunate things that did happen was the North Korean crisis. If you remember, that year, last year, the North Korean military fired some ICBM test missiles and got everyone seriously worried. On January 13th this year, if you were watching TV at home in Hawaii, there was a pretty nasty surprise for you.
The U.S. Pacific Command has detected a missile threat to Hawaii. A missile may impact on land or sea within minutes. This is not a drill.
That was some pretty scary stuff, right? Fortunately, as we have later learned, there were no actual missiles heading for Hawaii that day. It was a false alarm. But millions of people were terrified, and many have sent their farewells and last words to loved ones. So how did something like that happen? How did false missile alarm get broadcasted on TV? Well, that's the question that the FCC investigators need to answer, but figuring that out is no easy task. Obviously, the false alarm got broadcasted on TV because the TV station operator pressed a button to put it on the screen. But if you go ask him, he will tell you, well, I'm just doing my job because my manager called me up and told me to put it on the screen. And if you ask the manager, she will tell you, well, I got a call from the Hawaii Emergency Management Agency, so that's not my fault either. And following this chain all the way up to the top, you'll find out that, well, turns out this was supposed to be a drill at the EMA, so what went wrong? Clearly, there's some miscommunication going on there, right? Because on one hand, the supervisor at the EMA intended that to be a drill, but on the other hand, it came out as a real alert. So who didn't get the memo here? Well, according to the investigation report, the EMA supervisor initiated the unscheduled drill during a shift change. And despite including the phrase exercise, exercise, exercise as they're required to, he went off script a little bit and at one point said the phrase, "This is not a drill," mistakenly. And in turns, the employee responsible for sending out the alert claimed that he missed the exercise part of the announcement and genuinely believed there was an actual emergency. Supposedly, a coworker put the announcement on speakerphone partway into the message. That's basically all we know. So unfortunately, we don't have a very good record of what actually went down there. So that's basically all we have to work with. But wouldn't this be a lot easier if we have some sort of proper paper trail of who talked to who during that time? Even better, wouldn't it be nice if we can just freeze time in that moment and interrogate all the parties involved? Well, that probably sounds too good to be true for the FCC investigators. Luckily for us software investigators, this is totally feasible. And in fact, your computer is always trying very hard to give you this information all the time. So if you remember this red arrow thing that you see in the console all the time, if you don't know how to read it, it could be quite overwhelming. So why don't we try to use this format to describe what really went wrong in the Hawaii incident. So the top line is the error message, a description of what went wrong. This should always, always, always be the first thing you read, because if you get lucky, sometimes this is all you need to read to figure out what went wrong. But in this case, this is really just telling us something we already know, right? Like we know we send alert, we don't think we should have, and so the real question is, why did we do it? This is where the stack trace comes in, right? Like the scary looking thing at the bottom of the error is a paper trail of who talked to who, something that the FCC investigators would love to have in this situation, right? At the very top, that's where the error actually happened, right? So that's the TV operator triggering the alert, and the next line is why he did it, in this case, because the manager asked him to. And in turns, you can follow the trail all the way back to the EMA supervisor. And if you click on any file name in the stack trace, your browser will actually just take you directly to the definition of the function. So it looks something like this. So looking at the code here, it might be very tempting to just fix the problem right here, right? OK, we sent an alert, and we shouldn't have sent the alert, so maybe we can just double check with the specific command before we do it. Now, I totally understand why this might be tempting, right? Maybe this is the part of the code base that you know really well. Perhaps you just don't want to open the cans of worm that is sitting in the other file that is the legacy spaghetti code that predated you in the company. There's a bug in my code. I fixed the problem. I even wrote a test, and it passed, so problem solved, right? Well, there are two problems with that. The first problem, imagine how this code would look to the next person working with this code. Maybe they have to come fix a completely different bug, right? If that's me, I would probably look at this and think, well, I thought I knew what this method is supposed to do based on the name, but now reading the source code, I'm not so sure anymore, right? Like, why would this method even be called when there are no incoming missile? Like, what does that mean? Like, I guess probably that's probably because of some very complicated reasons that I don't understand yet, so I don't want to break things, so I'll just work around the problem somewhere else instead. And with that, history has repeated itself, and we have seen the full life cycle of how a spaghetti code base is formed. So that's problem number one. Problem number two is that we didn't actually fix the problem enough, right? Sure, we have prevented the TV station from broadcasting a false alert, but if you go a few frames up the stack, you will see that the system is also supposed to notify the cell phone providers to send SMS and push notifications. So we still have a problem there. Sure, we can add another conditional around it, but I think the better thing to do is probably get to the bottom of this and try to fix it from there. Remember what we said about freezing time earlier. This is what the pause on exceptions button does. If you enable it, refresh the page, it will freeze everything as the error is happening, giving you a chance to go up and down the stack and capture any evidence you might want and interrogate the parties involved. So similar to the stack trace and the error message, clicking through the call stack on the right would jump you directly to the function definition. However, because we are frozen in time, there are more we can do. You can probably see that it highlighted a variable there. Because we're frozen in time, you can use the console to basically try to poke at any value that might be in scope in time at that point in time. So here we can see that the problem is the employee is called with is drill set to false, but is exercise is undefined. So they generally believe this to be a real missile threat. So how come is exercises undefined here? Is that supposed to happen? To find out, we have to go up one level, and it looks like the problem is the coworker forgot to pass that option along, so we can fix that pretty easily. And after running tests, everything is green, and so like we're good to go. But is that good enough? Well, we can actually go one level further than that. If we go one more thing, we'll see that this is really a bug in the supervisor, right? Like, why are there two separate options for is drill and is exercise? We should probably just fix the supervisor so it doesn't go off script and pass two conflicting things in a critical moment like this. With that, we have eliminated some unnecessary code and untangle some of the spaghetti for future readers. So we fixed our first bug. We learned to read error messages. We learned to understand a stack trace. We learned to freeze time when exceptions are happening, and use the debugger to go up and down the stack to find the problem. Most importantly, though, we learned that debugging is not just about fixing the immediate problem. We need to dig through the different layers to find the root cause, and sometimes that might mean doing some refactoring upstream to prevent similar errors from ever happening again. All right. So that was quite a lot to take in, so I'll give you a little break. Let me tell you another story. This time we have to go back to 2003. On January 16, 2003, the Columbia Space Shuttle is ready to come home after spending 15 days on mission in orbit. Sadly, they never made it. The orbiter disintegrated completely during re-entry, killing all 7 crew members on board. So what happened here? If you were able to freeze time in this few critical minutes, you will notice that there is a pretty big hole on the left wing. So that's why it disintegrated, because it overheated when it was during re-entry. But this is only half of the story. The critical reason is why. The critical question is, why is there a hole on the left wing of an orbiter in the first place? Well, unfortunately, the ability to freeze time alone won't help you here. The event that led to the failure was actually happened much earlier. It turns out during the launch, a piece of foam broke off, hitting the left wing at very high speed, leaving a hole behind. And these kind of problems where the root cause happened in a much earlier time frame than the eventual failure is very common in both the real world and in software. In the Hawaii incident, we knew that the supervisor intended to perform a drill, but it came out wrong on the other end, so we know to look for the problem somewhere in between those 2 points in time. As we explained, the stack trace basically gave you a moment-in-time snapshot of the explosion, which is represented on the right-hand side here. But in this case, instead of just looking at the very last moment, we need to look at the whole timeline of the mission to figure this out. Now, we know that we didn't have a hole in the space shuttle before we launched it, we checked, and we knew that there was already a hole before the reentry, so our answer must lie somewhere in between these 2 points in time. So instead of going up and down the stack, we need a way to go back and forth in time in this case. And unfortunately, time traveling is actually quite difficult, but what we can do is freeze time in some of the key moments in the timeline and inspect them individually. This is what breakpoints do. You can add breakpoints to your code by using the debugger statement, which some of you are probably already familiar with. When the browser encounters one of these debugger statements, it will pause the execution, giving you a chance to inspect everything. And as you can see, we're currently paused in the time just before the pre-launch status check. Just like when we were paused on an exception, you can navigate up and down the stack and inspect any variables that are in scope. But there's one additional thing you can do here. You can go forward in time in a very precisely controlled manner. The step over button let you go forward in time one statement at a time. Despite the pretty rude name, it is usually a pretty good default because it tries to keep you in the current stack frame so you won't feel too disoriented. So clicking on that will advance time one statement at a time inside the current function. And in this case, it will perform a status check in a different team in the mission control every time you click that button. So far, so good. But as we learned, sometimes we need to go deeper than that. So here, we paused right before we pulled the flight director for the go or no-go decision. But what if we don't want to just take the word for it? What if we want to double check to make sure they're doing the job correctly? That's where the step into button comes in handy. Instead of just calling the function and going over to the next line, it brings you into the implementation of the function. Once you're inside, everything works exactly the same way. You can keep going forward one statement at a time. You can keep going deeper if you want. And in this case, I'm happy with what I have seen here, so I decided I don't need to micromanage them any longer, in which case you can use the step out button, which for Canadians, I find it rude AF, but naming aside, it does what you would expect. If you, it will keep going forward in time until you have returned out of the current function back to the previous stack frame. So, and I won't waste your time here, so if you think you can trust the rest of the teams, you can just click the step off function again, and we'll be back to will be put back in the previous stack frame. So finally, when you're done inspecting the current time frame, the resume button will advance time until the next breakpoint if you have one. So at this point, you're probably thinking, yes, I feel invincible. I can debug anything now, so can't wait to try this in my Ember app. Well, before I let you off and go do that, I do have a few warnings for you. Remember when, at the beginning, when I said the debugging experience in Ember could sometimes be less than amazing? Well, I'm going to tell you what the problems are, why they exist, and what you can do about them. So the first problem is, there are usually a lot of things in the call stack in an Ember app. So this is, I believe, a screenshot from Skylight, the Ember app. So part of the problem, well, part of the reason is that Ember is doing a lot of legwork for you, like managing the run loop, or so by the time the hook that you implemented is called, there are already a million things in the stack, and if nothing else, that just makes everything feel very overwhelming. And the other part is that you will often be going through a lot of Ember abstractions in an Ember app that is intended to make your life easier when they're working properly, such as this underscore super, right? So if you try to step into this, what you will end up inside the Ember super wrapper function, as we call it, instead of where you probably want it, which is the implementation you inherited from your super class, right? So of course, if you keep stepping, like this is not magic, so if you keep stepping, you'll eventually end up in the place you wanted, but you would have to first understand how you got here in the first place and like what on earth you're looking at, right? So would be nice if you don't have to do that. To solve this problem, you can use the framework black boxing feature. The easiest way to do it is just right-click on any frames that you don't want to see, and you can click black box script, and as you can see, they go away. So it's hidden from you in the call stack on the right-hand side, but more importantly, now when you try to step into it, you will end up directly inside the super class implementation instead of going through the this underscore super wrapper. So essentially, you can label any code that is part of Ember and treat them sort of like native code in the browser. You don't really need to look at their implementation because generally you can just assume that they work. If you don't want to black box everything one by one, alternatively, you can also go into the developer tool settings and black box the entire vendor.js file. And with that setting, you can see that everything in your from Ember or other dependencies where they come from NPM or other sources will be hidden away from the stack trace, from the call stack on the right. And you can see that in this case, all we have left is code we have written in our application, and that even fit inside one screen's worth of space, so that's pretty neat. A word of caution, though. A lot of time, ignoring the whole vendor file might end up hiding too much stuff that you might actually want to see. In particular, you might want to look at the implementation of some add-ons, or sometimes if you have pause on exception turn on and the exception happens inside the black box code, like maybe an ember.onError, it doesn't pause correctly. So it probably takes some tweaking to find the settings that work best for your team. But black boxing the vendor file is certainly a pretty good starting point. And okay, on to the second problem with debugging in Ember. This is essentially the same kind of problem as we encountered in the Columbia Space Shuttle problem, right? Where the root cause and its effect is very, very far apart. As we saw earlier, sometimes black boxing helps a little bit here. I don't know if you can see that, but you can see at the bottom frame is basically the model hook and application route, and you like go through all the layers, even including async code to your serializers and adapter. So that's pretty neat, but sometimes the browser could never figure it out for you. For example, you might have loaded some data in your parent route, and you didn't notice that you have a bug in your adapter. So like it's not until way later when you try to access the data in your child route that you notice that there's an error, or maybe there's not even an error, there's just a blank screen of nothing, right? As far as the browser is concerned, those are completely separate events, so it will be pretty hard for the browser to tie them together for you. And arguably, this problem is not really unique to Ember, but it certainly is very common in Ember apps because of the way we tend to do things in Ember. In this case, you basically have to remember the tricks we learned from the Columbia Space Shuttle example and basically drop in breakpoints and strategic times to investigate the situation. In summary, you should try to ask yourself, what did I expect the code to do? And can I find a point in time where it was still behaving correctly? And from there, you can see when did it start diverging from your expectation, and from there you can use the tools that we learned here to narrow in and find the root cause of your problem. Finally, I will use the remaining time, by which I mean the first 5 minutes of your snack break, to show you an assortment of tips and tricks that may help you in your journey. I'm going to go through these very, very quickly, so don't feel bad if you can't follow along. You can always rewatch this part when you're running into problems. So let me drink some water. And here we go. So number one, breakpoints. So far, we have been talking about using debugger statements in your code, but you know you can also add them directly from the developer tools without editing and saving and reloading. You can just click on the line number, and boom, there you go. To remove it, just click it again. Now, you can even turn it into a conditional breakpoint by right-clicking on it and select Edit Breakpoint. And for example, you can turn this into a conditional breakpoint that only trigger when the status is not 200. So when you have an error from the server, you will trigger this breakpoint, otherwise it would just go through. And for comparison, this is the equivalent code that you would have written in your code for the same effect. And finally, you can also set a breakpoint that triggers whenever your app tries to do any AJAX requests, or you can scope it more narrowly by matching certain URLs. So in this case, I matched it to me.json, so it triggered the breakpoint when the app is trying to load the user profile. Next, continuation. So let's say you have a breakpoint at the top of a function, and you want to fast forward to the middle of it. You can just keep pressing step over, but you can also just right-click on the line and say continue to here, and it will just do exactly that. Sometimes you may have the opposite problem, where you have a debugger statement in a for loop that is triggering too many times because you're looping through a very big array. You can right-click and select never pause here, or alternatively, you can click on the resume button, and you can click and hold on the resume button, and you can press the play button instead, which will ignore the breakpoints and go all the way to the end. Next up, debug functions. So you might have a lot of console.log statements in your app. They're pretty useful for debugging, but maybe you don't want to ship them to production where they will spam your customer's console. So do you know that Ember provide a debug function from the @ember/debug package? The nice thing about them is they are stripped in the production build, so you won't have to worry about the noise that they produce, but also they won't increase the file size of your app, or they won't slow down your app if you're doing any expensive inspection inside the message. Along those lines, you can also use the assert function. That is pretty useful for verifying some assumptions that you might have made in your code. which can often help you catch bugs before they become a problem. If nothing else, it is a pretty good way to communicate to your readers that you expect certain things to be true all the time. They also strip from the production build, so you can sprinkle them in pretty liberally without worrying about performance or file size, etc. Finally, templates and debugging templates in UI. Did you know that there is also a debugger statement you can use in handlebars that would bring you into the JavaScript debugger, so you can, just like a real debugger would. So from there, you can have access to your block params or your context object, etc. So that's pretty handy. And separately, you probably already know about the Ember inspector, but did you know that anytime you see the $E button, you can click on it, and it will send the object to the console in the $E global variable, so you can play around with it. And by the way, while we're here, anytime you see a function in the console, you can right-click and click show function definition, and it would bring you directly to the source code. This is pretty handy if you have something like the actions hash where you're trying to figure out where the functions are coming from. Oh, and also, by the way, if you have source maps, you can do Command P or like probably Control P on Windows, and you can start typing a file name, and it would open up the file you want. Like you can do, for example, Command P and type routes/application, and it will generally do it right there. And over in the elements panel, similar to the Ember inspector, every time you select an element, it will go to the $0 global variable, so you can also play around with it in the console. And you can also right-click on it to trigger things like hover state or focus state, which are generally quite tricky to reproduce when you're debugging in the console, right? Like you can't use one hand to hover it and type at the same time, so this will come in handy. And finally, one last thing, you can select an element and set a breakpoint on it so that every time that element is updated in any way, it will put you in a JavaScript breakpoint. This is pretty handy for debugging rendering problem where Ember is adding or removing nodes or attributes that you didn't expect and you don't know where they come from or what triggered it. So yeah, you can basically use this to set a breakpoint, so you will have an opportunity to investigate that. And that concludes my talk, and I hope that no matter where you're at in your debugging journey, you will feel more empowered in some way after the talk. And because in my opinion, I think debugging is one of the most important programming skills you could learn that is not often talked about enough. So once you have mastered debugging your own code, you can start peeling away the black box by stepping into the source code of libraries that you depend on to understand how they work. And from there, fixing bugs and sending pull requests to these libraries, or even Ember itself, is only a small hop away. And that's how I personally started contributing to open source, and maybe one day that could be you too. So that's it. Thank you very much.